Okay, so a little bit of vocab for you. Instantaneous rate of change is called the limit of the average rates as the time interval gets closer and closer to zero, right? So I keep getting closer and closer to the time period that I want. That's like less distance in between the two time periods. And the number that those answers are getting closer and closer to, right, is the instantaneous rate of change. This limiting value is called the derivative. That is really, really important in calculus. We'll talk way more about that. But the connection you need to make is the instantaneous rate of change, or how it's changing at one time period, is the same thing as saying the derivative. So just from a laziness standpoint, right, I am unlikely to write out this phrase if I can just write this word, right? Instantaneous is one that I often misspell because I kind of get lost in the middle, right? But I'm pretty confident that I can get through derivative. So the big connection for you is instantaneous rate of change is the same thing as the derivative. Okay. The next thing I want to talk about is talking a little bit about the rate of change given a graph. Okay. And so if I give you this graph, we can kind of take a look at how is the graph changing, or what is the slope at a certain value. Okay. So the first one here is at x equals a, right? At x equals a, this is the point on the graph. And so if I draw a little line that represents, maybe I should have made my dot so thick, the slope at that line, do you notice that it's touching my point and that's kind of it? What do I know about the slope of that little segment? Well, I definitely know that it has a positive slope, okay, which means that the graph is increasing. Okay, and then it says also say if the rate of change is fast or slow. Well, obviously fast or slow is a little bit of a judgment call. What I like to say is if I was going skiing, right, and I'm really not a good skier, if it's a black diamond, then it is likely to be something that I would say is increasing fast, right? This is a steep curve or a steep slope for me, and so I'd say increasing fast. Okay, positive slope is saying the same thing as the derivative is positive, right? Because the instantaneous rate of change is the same thing as the derivative. Okay, let's talk about B. Okay, so over here, here's the point B. If I draw in the slope of a line, right, that touches at B, I think it is pretty clear that this would be a negative slope. And because that is a negative slope, then I know that it must be decreasing there. And I would say this is a pretty gentle, like almost I would be okay handling that on skis, right? So I'm going to say decreasing slowly. And then the last thing I want to add is if you have a negative slope, that means that the derivative is negative. Okay. And then finally at C here, well at C up top, if I draw in this, boy, that doesn't really look like it has any sign at all. Okay, so I would say this is a situation where there is, the slope is 0. Okay, which means it is neither increasing or decreasing, right? And that also means that the derivative is 0 at x equals c. Okay, so it's literally that easy. You can take a look at the graph, decide if it's increasing or decreasing, slowly or quickly, and that also tells you some information about the derivative.